The New Future of Making on Mars, a tutorial conference for students. Discover possibilities for you to take part in the exploration of Mars. 5 tutorials, 1 plan for building a science station on Mars, 1 veteran's guess about the future, 1 super interview on hot robotics in Leo, 1 conference summary, 8 subject matter world experts from NASA, top universities, and 3 space companies. Sponsored by the Mars Society of Canada, MakerWorks of Ann Arbor. Organized by 2 Planet Steel. See possibilities you haven't seen before. Brian Hynek, professor of planetary geology at the University of Colorado, brings Mars to life in this talk. Meridiani Planum, Mars, a history of water and a future of in-situ resources for humans. Hynek focuses on the region explored by the legendary Opportunity rover. He explains how this place fits into the larger story of Martian geology and discusses why the Meridiani Planum was chosen as Opportunity's landing spot in 2004. Orbitally detected signals from not 1, but 2 fundamental resources attracted NASA to steer Opportunity to a Lake Superior-sized equatorial region within the California-sized Meridiani. Hynek also looks forward, challenging us to think ahead to how the discoveries in this region could shape the future of Mars exploration.
So I'm a professor of geology, planetary geology. I spend a lot of time studying Mars and most all my time. And yeah, I want to tell you about Meridiani Planum, which maybe will become Ironberry Farm or something eventually. But
I
where we
hope so. That's for
rovers.
tomorrow. You don't want to talk about too much about that, but I'm looking forward
All
to
right, all
hearing
right.
what you have to say.
Yeah. So, this is one of the places we've sent a rover to Mars and very capable rover with a lot of instrumentation. And, from my PhD work until now, for the last 20 plus years, just we're still writing papers about this amazing spot that we went to on Mars. So I just want to talk about that and give you a little background on the history of Mars. And so yeah, right, NASA and others, Mars is a target. We have, geez, there's 7 different satellites at Mars right now, 2 rovers on the ground, and sending back data every single day and learning amazing things. And we want to, as a humankind, as NASA, to understand the potential for life at Mars in the past, what the climate history has been, the geology, and then also get ready for humans. So that's what we're after. And the cross-cutting theme, of course, is water. So we want to understand when water was there and in what capacity. So I've done a lot of work sort of understanding the Mars data and trying to look at, trying to infer from the geology what we can understand about the past climate history and when water was there. And the biggest sign of long-lived water on Mars are these dried-up riverbeds. We see them all over the place in the ancient highlands of Mars. And, these lasted for millions of years, or it took millions of years of water flowing on the surface to be able to carve these things. So we know there was a lot of water based on these features. And then we also see deltas in places. So sediment-filled river flows into a standing body of water, and then all of a sudden, it dumps all that out and you make a delta. And we see these around Mars. So again, signs of standing bodies of water there on Mars, long, long time ago. And then a third line of evidence that there was a lot of water flowing around on the surface of Mars back in the day is that we see these minerals that are, clear signs of water interacting with the volcanic rocks that were on the surface of Mars for a long time. So we see different types of minerals. All of these spots here are places where we had a lot of water around. And then, so let's focus in on Meridiani, where there's a lot of these sulfates and also the iron oxides that we find. So, whoops, let me go back one. All right, so why did we choose this as a landing site? So yeah, I was helping figure out the landing site and where we should go, because you don't want to just go anywhere. You want to go to the best place. And this place had this hematite signature from orbit we could see. And it was clear evidence that there had been a lot of water interacting with the rocks at this place. And On Earth, a lot of these we call them banded iron formations. The iron is hematite, and that's the great parts here. And so clearly there was a lot of water around this environment. That's why we went. Here was that whole sequence that happened. Like it started with parachutes and then had this giant airbag system that had bounced across the surface of Mars for almost 10 minutes before it finally came to rest inside of a crater. So that arrow that shows opportune lander, it ended up right in a crater there, and it was really interesting. So there's its view from this crater, Eagle Crater. It became named, and you can see the white parts in the back. That's all bedrocks, which are really interesting and encapsulate all the water that was there. And it drove across these broad plains. Here's just some pictures of what it looked like. Went and saw other craters, went and studied rocks. Had this arm that had all the instruments out on the end of the arm that it could, really give us a lot of good information about what particular rocks and chemistries and things had happened there. And then here's again some context pictures of where this thing was and what it looked like. And what we found was there's an enormous amount of iron in the rocks and an enormous amount of sulfur in the rocks as well, and in different forms. But all of it is indicating that there was a lot of water that flowed through this system, for a long, long time. And so, yeah, at this site, this signature iron, we were expecting maybe things like those banded iron formations. We didn't find that. It's always surprising when you go to Mars, but we found these balls that are on the left side of the image here. These are spheres of iron oxide, of hematite. And that was the signature iron that we were seeing there. But then there are also all these calcium sulfates and other sulfates around with lots of water that's bound into the mineral structures. So again, telling us there was a lot of water around for a long time there. And so what did the summary of 14 years worth of work here for this little rover on Mars, which again was only supposed to last 90 days and go, I think, 600 meters was mission, goal, and it instead went, over 30 kilometers. But it found all this really interesting water altered bedrock that was there. So again, all the sulfate, all the hematite that's there. And so clearly there was a lot of water around. There were probably dunes. There were times when there were lakes. There were times when there were rivers here. And all this stuff happened together, and then now is preserved there. And so, I was, again, working with the rover data, and then we sort of put together the broader geologic context to try to understand this, right? So like in this one spot, the rover found really cool stuff, but how widespread was that? And so we did a lot of geologic mapping. Everything in pinks and purples there are places where you have all these water altered bedrocks, and the rover was in the lower left side there. And so, yeah, here again highlighted, that red little dot there is the where the rover was. But it's not like just what it found there was really cool. It extended over something as big as the Western US, right? A huge area, really thick sedimentary rock deposits there that are, again, full of iron and all these hydrated sulfates. And so, the iron, instead of being ancient seabeds like we expected or thought might be there, it was in these little balls. And so this false color image, all those yellow circles are these little balls of iron that are sitting there. And we found them for the entire traverse of the rover. And so I had a student that helped me look at all the microscopic imaging images of Mars from this rover, and we mapped out how much iron there was and where the iron was and whether it's covered in the whole ground or it's just a part of it, and just trying to understand that, where this is coming from. And so, we did this all across Mars, or followed the rover and did all this mapping, and what we ended up with is trying to understand how much iron is there. And so right, ISRU, in situ resource utilization, obviously we need it at the moon, we need it at Mars, and at a minimum, say 40-to-1 ratio here of how much rocket fuel you need to get something to Mars. Maybe it's 100-to-1, 200-to-1, I don't know. But you need a lot. So you want to deal with what's there and then be able to utilize that. And so again, just maybe 4 people on Mars need 2,000 kilograms of oxygen, 25,000 kilograms of water for a Mars mission. So, and this is no small task, right? This is like 5 SLSs or a couple of the minimum starships to get that much stuff to Mars. So we want to be able to use what's there. And this is a great spot for it. And, sort of this picture from the rover, that Meridiani Planum, where that rover went, it's a great spot because you have all this iron just laying on the surface, and then you have all these rocks underneath that have water within the mineral structure. And so you can utilize the iron and the water. And, hopefully Rolf's gonna make me a partner here.
Yes, yes, I am. Thank you very much.
All right.
You're queuing me up for tomorrow.
All right. So yeah, but look at all this iron is just sitting there. So here's just a couple just mass balance calculations or whatever. But for these little balls of iron that are there, and the density. So every single one of those circles of iron there, those marbles have maybe 70 grams of iron in them. And this area is huge. It's
Right.
something like the Western US, right? And from the rover observations, about half of the ground is covered with these balls of iron. And so you end up with, maybe per square kilogram or square kilometer, you end up with 1 billion of these little balls of iron. And you add up the mass of those, and you're looking at, nearly 100,000 tons of iron. And this is really pure iron too. It's, on Earth, a lot of the hematite it's rust. You have this, it's not in the right form, but this stuff is really, really, really pure and good iron for you. And then, right, so water also is very important. So if we, again, take the same sort of volume of these rocks that we've mapped out, and if maybe 20% are these hydrated sulfates, then you end up with something like 85 liters per cubic meter of rock of water that's just sitting there in the rocks at Meridiani. So yeah, it's a great spot to go. That's a lot.
We just need electricity to heat up those rocks, or some kind of energy.
Exactly, right. So yeah, it's I mean, in terms of a place to go and land, one, it's very flat. We've been there, we understand it well, but there are a lot of these in situ resources that certainly will be needed for humans. And so yeah, with that, I'll just end and happy to answer any questions about anything. Thanks very much.
Thank you, Brian. Did everyone notice that iron ore was just lying on top? You can just pick it up.
Yeah, it's just sitting there everywhere we drive. Yep.
You don't have to dig for it.
Yeah, look at that big pile right there. That's 100 kilograms just sitting right there.
Right. Let's see. Brian, a lot of this work was done, 15, 20 years ago. What are the key things that have been done in the intervening period?
Well, no, it's still, we're still writing papers about the latest results. And the rover died probably 2017, I think, maybe
Right.
2016, but still that data from then we're still analyzing and studying and writing papers about. So yeah, a lot's still happening, and then again it's putting it in this broader context. So
I want to bring up this 2015 paper by Flahoe et al. There was a great paper from 2015 by people from Johns Hopkins and ESA, and
Mm-hmm.
they were really working off of Brian's idea that the water where all the iron was there's just as much water as what at an area over to the west of the iron area which Brian calls the etched terrains. And Brian figured that all out, and this Flahoa et al. Paper in 2015 basically confirms Brian's idea that there was a lot more water underneath a layer of soil and this hematite, which all these orbital sensors were having a hard time picking up. John Hopkins and ESA went back and managed to get some rather more high resolution data and confirmed Brian's ideas that there's just as much water with the iron as there is to this etched terrain region off to the east.
Yeah, I think so. And then ESA, right there, ExoMars rover that was supposed to have launched already, but it was going to fly on a Russian rocket, and then things went haywire there. So NASA's hoping to launch that, but the landing site is in Meridiani Planum, and so we should get another look at somewhere in Meridiani within the next 5 years, hopefully.
Right.
You have just heard a talk in the conference for students, The New Future of Making on Mars. People like you are taking part in the exploration of Mars. You can too. This online conference is sponsored by the Mars Society of Canada and MakerWorks of Ann Arbor, Michigan, and organized by 2 Planet Steel. Please like, subscribe, and watch more conference videos.